In this video, we are going to solve problems based on similar triangles. To solve these problems, you need to know basic proportionality theorem and converse of basic proportionality theorem. If you don't know either of these, then before understanding these problems, please do visit our website to learn the same. So now, before we go ahead and start solving the problems, let us first revise these two theorems. The first is the basic proportionality theorem. It states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Say for example in triangle PQR, if ST is parallel to QR, then PS upon SQ equals to PT upon TR. Now, the converse. It states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So, for example, in triangle PQR, if PS upon SQ equals to PT upon TR, then ST is parallel to QR. Now, let us look at the question. It says, if three or more parallel lines are intersected by two transversals, prove that the intercepts made by them on the transversal are proportional. So here we have been given that three or more parallel lines are intersected by two transversal. We'll consider the three parallel lines X, Y and Z cut by transversals AB and CD at points E, F, G and PQR respectively. We have to prove that the intercepts made by the parallel lines X, Y and Z on the transversal AB and CD are equal. That is, we have to prove that EF upon FG equals to PQ upon QR. So, first we'll construct a line EN parallel to CD meeting lines Y and Z at points M and N respectively. Now, as we know, X is parallel to Y. Therefore, we can say that EP is parallel to MQ. And since we constructed EN parallel to CD, we can say that EM is parallel to PQ. Therefore, in quadrilateral EMQP, EP is parallel to MQ and EM is parallel to PQ. Since the opposite sides of a parallelogram are parallel to each other, we can say that EMQP is a parallelogram. And because opposite sides of a parallelogram are equal, we can say that EM equals to PQ. We'll consider this as equation 1. Similarly, we can prove that the quadrilateral MNRQ is a parallelogram, as MQ is parallel to NR and MN is parallel to QR. Therefore, quadrilateral MNRQ is a parallelogram. Since opposite sides of a parallelogram are equal, we get MN equals to QR. We'll consider this as equation 2. Now, in triangle EGN, FM is parallel to GN. This is because Y is parallel to Z. So, by basic proportionality theorem, we get EF upon FG which equals to EM upon MN. We'll consider this as equation 3. Now, from equation 1 and equation 2, we know that EM is equals to PQ and MN equals to QR. So, by substituting these values in equation 3, we get EF upon FG equals to PQ upon QR. Hence, it's proved. Now, we'll solve the last question of this video. It says, the sides QR of triangle PQR is bisected at S. O is any point in PS. QO and RO produced meet PR and PQ at T and U respectively. And PS is produced to X so that S is the midpoint of OX. Prove that PO upon PX equals to PU upon PQ and show that UT is parallel to QR. So here we are given that S is the midpoint of QR and OX, and we have to prove 1. PO upon PX equals to PU upon PQ, and 2. UT is parallel to QR. So before we go to finding a way to prove this, we'll first join QX and RX. As we just now saw, we are given that S is the midpoint of QR. Therefore, QS is equals to SR. Consider this as equation 1. And also, S is the midpoint of OX. Therefore, OS is equals to SX. Consider this as equation 2. So, from equation 1 and equation 2, we can say that QR and OX bisect each other at point S. Now, if you observe quadrilateral OQXR, you can see that QR and OX are its diagonals. And as we saw just now, QR and OX bisect each other. Therefore, in quadrilateral OQXR is a parallelogram, since diagonals of a parallelogram bisect each other. One of the most important property of a parallelogram is that opposite sides of a parallelogram are parallel to each other. Therefore, in quadrilateral OQXR, RO is parallel to XQ and XR is parallel to QO. So now we can say that RU is parallel to XQ and XR is parallel to QT, and also OU is parallel to XQ and XR is parallel to OT. This is possible because points ROU and points QOT are collinear points. Now, in triangle PQX, OU is parallel to XQ. Therefore, by basic proportionality theorem, we get PU upon UQ equals to PO upon OX. We'll consider this as equation 4. By cross multiplying, we get UQ upon PU equals to OX upon PO. By adding 1 on both the sides, we get UQ upon PU plus 1 equals to OX upon PO plus 1. By componendo, we get UQ plus PU upon PU, which equals to OX plus PO upon PO. But since UQ plus PU equals to PQ and OX plus PO equals to PX, we get PQ upon PU equals to PX upon PO. On further cross multiplying, we get PO upon PX equals to PU upon PQ. Here, we prove the first part of the sum. Next, we have to prove that UT is parallel to QR. So now, we will first consider triangle PRX, where OT is parallel to XR. By BPT, we get PO upon OX equals to PT upon TR. Consider this as equation 5. from equation 4 and equation 5, we get PU upon PQ equals to PT upon PR. Thus, we can say that point U on PQ and point T on PR are such that they divide PQ and PR respectively in the same ratio. Therefore, by applying converse of basic proportionality theorem, we can say that UT is parallel to QR.
So that's it for today. Hope you have liked the session. If you want more such sessions, then do subscribe to our channel. You can also now check out our courses available on our website www.letstute.com. Until next time, keep watching, keep learning.